Now what we want to do is to change the sort order. So we're going to go into Format. The default is to order by ascending values, and what that means is 0 is going to come first, followed by a penny, whatever. We're going to change it to descending counts. So check off descending counts, then go hit OK. So what you'll see is that the most commonly occurring down payment, which is $100, comes first. The next most common down payment is $150, then followed by $50. So you'll see everything's kind of a multiple of 5 until you get to $19, which is probably a promotion of some sort. All right, so sometimes it's very useful to have a frequency distribution like this, because you can see which values are occurring most frequently, and SPSS enables you to change the sort order. Let's move on. Part J, compute the base 10 logarithm of down payment. Generate its histogram, describe its shape. Why are there so many spikes? All right, so to make a new variable, let's go into transform, and we're going to go into compute. We need to give it a name. Let's call it log down. Now, if you're not sure how to take a log, you use the help over here. So logs are probably under arithmetic, and look for something that looks like a log. LG10, if we go click on that, you'll see it returns the base 10 logarithm of some numeric expression, which must be numeric and greater than 0. The reason is you can't take the logarithm of 0. So I'm going to bring that up, and then we're going to bring down payment in. Now recall that down payment can equal 0. So the way we can avoid that problem is simply to add 1. So if we start out with someone who puts 0 down, 0 plus 1 is 1. Base 10 logarithm of 1 is then 0. So go ahead, OK. And what you'll see is that in the data set you now have a variable called log down. If I scan down here, I see a 2. At 2, remember that 10 to the second power is 100. We go look at the down payment, sure enough it's 100. So I think we did this right. Let's go up to Graphs, Legacy Dialogues, and a histogram. We're going to bring log down in. I guess we got to get that out first. Then we can bring log down in. Go hit OK. And what you'll see is a distribution that is vaguely normal but has these large spikes. Now I asked, what are these spikes? Well, these spikes are the frequently occurring down payment values. Recall from that frequency distribution that $100 down, which is at 2, was a very common value. Nobody puts $101 down, but lots of people put $100 down. So that's why you get that spike. This is probably 150, this is probably 75, this is probably 50. And so by taking the log, we can reveal some of these features of the data that we couldn't see in that original histogram because everything was so bunched up in that one bar. Let's move on. What percentage of people have use equal to 0? So I'm starting to not give as many hints, although in my answer I give a hint. So how could we find that? The easiest answer is to generate a frequency distribution. So we're going to go up to Analyze, then Descriptives and Frequencies. I'm going to reset everything, which will restore the original sort order. I'm going to copy use in and go hit OK. And so what we'll see is there's about 39.7% of our database who have a value of 0 for use. Moving on, change the format of enrollment date to month, day, year by clicking on the variable View tab and changing the type. All right, so my point with this is that we can change the way we display a date to anything we like. It's stored as the number of days since start of the Gregorian calendar, October 15th, 1582. So it's stored as this big number, and then we can display that any way we want. So I said to use month, day, day. So we have to go find that here. Probably up. Month, day, day, year, year. And if I go hit OK, we come back. Now you see it as month, day, day, year. And you could change it to anything you like. You know, if you'd rather see it as day, day, dot. So if I go hit OK, notice you'll see now it's displayed. I guess that's the way the European style, and we can choose whatever we like here. Let's go back to what I had originally recommended. So we can just, all right, well, I like that better. All right, now part M says extract the month from enrollment date and submit a frequency distribution. So I give some hints. We're going to go to transform compute, and we'll make a brand new variable. Let's call it month. I'll get rid of this. And I actually give you the formula, but I think it's more useful to construct that formula. What you'll see in these functions are things for date extraction, date creation, date arithmetic. Let's go to date extraction. And if we go look at xdate.month, this says returns a month, so some integer between 1 and 12 from a date value. So let's bring that up, and I'll copy enrollment date in. Go hit OK. And so now we have a new variable that will take the value 1 if it's January. I guess 7 here would be July, and so forth. And we're also to submit a frequency distribution. So let's go up to descriptives frequencies. I'm going to reset, and then we'll bring month in. Go ahead, OK. And what we'll see is that you see a few more people joining in January, February, and March, and then it falls off. Now, I don't know if that's because we have more January, February, and Marches in the data set, or if people just try to lose weight after Christmas. But you know, the point of this exercise was to show you how you could strip off part of a date, like a month or a day of the week or a year, and do things with it. Okay, so that's the end of this exercise. Oh, actually, we didn't do part N. Part N was save. So let's go do a Command S. And so we just saved, and now we're done.